This is 5.1, Properties of Parallelograms. The chapter 5 is about quadrilaterals, which is the polygon with four sides. Any shape of four sides is quadrilaterals. So chapter 1 we did terms of geometry. Chapter 2, truths or proofs. Chapter 3 was parallel lines. Chapter 4 was triangles, and now chapter 5 is quadrilaterals. Okay, and we start with parallelograms. This warm-up is exploragon exercise, which you can do at home because you don't have exploragons. But after you watch the video, I want you to list the characteristics of parallelograms here. Okay, all that you can think of, and then we go over that. Okay. All right, so it has it actually only have 5 sections. This is a short chapter, for this packet, there's only one objective: apply the definition of a parallelogram. I call it para. I'm sorry, you couldn't see. Parallelogram and the theorems about properties of a parallelogram. Okay. All right, so here's a definition. The definition of parallelogram is that it's two sets of parallel lines. That's what this is. Quadrilateral with both pairs of opposite sides are parallel. That's what it is. These are parallel and these are parallel. That's the definition of parallelogram. Everything else is a theorem. Okay, and these are the theorems. That's a 5.1, 5.2, 5.3 are the characteristics of a parallelogram, and actually, yeah. So we're gonna prove these. Okay. All right. So the first one is opposite sides of parallelograms are congruent. So the definition of parallelogram are that these are parallel and these are parallel. Now we are saying that these are actually congruent and these are congruent. That's what we are trying to prove. So if you want to make these congruent and these congruent, you probably want to make these two triangles congruent, right? Then these are corresponding sides. So you start with EFGH is a parallelogram. This is the mark for parallelogram. It looks like this. Okay, so that's a parallelogram sign. So this means that EFGH is a parallelogram, and we have to prove that EF is HG and FG is EH. Okay. All right. So you got these angles. So we start with these parallel. If these are parallel, then 4 and 3 are congruent by alternating triangles. If these are parallel, then 2 and 1 are congruent by alternating triangles. So these are congruent and these are congruent, and this is shared. So that's angle, side, angle. These triangles are congruent, and then it's CPCTC. Do we need to write this? I don't think so. You can write this, right? So this is angle, side, angle. It's alternate interior angle, and then that's a theorem, and then angle, side, angle, postulate, and then CPCTC. Okay. All right. This one, opposite angles of parallelograms are congruent. All right. So what it's saying is that this one doesn't have a diagram, but these are congruent and these are congruent. So how do we prove this? If we make these two triangles congruent, then those opposite sides are congruent, right? And then you have to repeat the same thing over here. Okay, so I'm just gonna do these. Actually, no. Yeah. By doing this, you can make these congruent, but not these. Can I make them? All right, let's try this. All right, So let's call this 1, 2, 3, 4. Okay, so then because these are parallel, 2 and 3 are congruent, right? And 1 and 4 are congruent. So angle addition postulate, you can do the 1 plus 2, measure bangle 1 plus measure bangle 2 have to equal measure bangle 3 plus measure bangle 4. Because those are congruent, so these are congruent, right? And then once you made that, these are angle side angle. These are corresponding angles, so they are congruent. So maybe we write this one, okay? So 1, well, we start with, I don't know, A, B, C, D. So A, B, C, D. 2, AD is parallel to BC, and AB is parallel to DC. Definition of parallelogram. So angle, measure of angle 3 equal measure of angle 2, measure of angle 1 equal measure of angle 4, alternate interior angle theorem, and measure of angle ABC is measure of angle 1 plus measure of angle 2, measure of angle ADC is measure of angle 3 plus measure of angle 4. And since 3 equal 2 and 1 equal 4, you can double substitute this into here to make measure of angle ABC is measure of angle 3 plus measure of angle 4. I'm sorry, this was angle addition postulate, and this is substitution property of 3 into 4. So now these are the same, so you can set measure of angle ABC equal measure of angle ADC, substitution of 4 and 5, and opposite angles are congruent, so angle ABC is congruent to angle ADC. So that's one opposite, right? So angle B is angle D. Now, we already said 2 and 3 are congruent, 1 and 4 are congruent. So we say BD is congruent to DB, and that's reflexive. And triangle ABD is congruent to triangle CDB, and that's angle side angle postulate. So angle A is congruent to angle C, CPCTC. Oh, sorry, you couldn't see any of those things I was writing. All right, here it is. So I made these by alternating triangles and angle addition postulate, and then I made these two triangles congruent to make these congruent. If you wanted to draw this one and repeat the same thing, angle addition postulate, you can do that as well. Okay, so that's theorem 5.2. 5.3, diagonals of parallelograms bisect each other. So this one, we want to say that these are referring to the angles, okay, but we want to make these congruent and these congruent, right? Then they would bisect each other. These are congruent and these are congruent. So if I make the triangle TQM congruent to RSM, then those are corresponding sides. So that's what we want to do. Okay, and then these are vertical angles, and this is parallelogram, so that means that these are congruent. Those are alternate triangles. And we already proven the opposite sides are congruent in 5.1, right? Opposite sides are congruent in 5.1. The opposite sides of parallelogram are congruent. So we can use that and said these are congruent, right? Because that's a theorem that already proven, we can use it. So then it's an angle side, okay? And then that's CPCTC. I don't think we need to write this. So use if quad is para, then opposite sides are congruent. And then use angle side theorem to make triangle TMQ is congruent to triangle RMS, then CPCTC. Okay? These are not bad, right? All right, and then the practice. So you do these two for homework, okay? And let's do even, and then you do odds homework, okay? So let's do this one, okay? We have to find the value of x and y, and it is a parallelogram, okay? So opposite sides are congruent, so x have to be 56, and these are parallel, so z have to be 85, right? And then y, so this is 85 and this is 56, so this have to be 180 minus these two. So y equal 180 minus 56 minus 85. What do you get? 39. Okay, so you can do the rest. Let's see what else. All right, so you do homework, and then we do this one. Okay, the quad, must quad EFGH be a parallelogram? Can it be a parallelogram? So question is, does it have to be parallelogram, or can it be parallelogram, or it cannot be parallelogram? Okay, all right, so let's look at it. If we add these, now these are parallel, right? If these add up to 180, and they do add up to 180 because these are the same side in triangle, so that makes these parallel. But we don't have any information about these two lines being parallel, so this could be, can be, but not sure, but not must be. Okay, so that's what you are trying to do on these. Okay, that either can be or must be or cannot be. But doesn't have to be. Okay, let's go over here. The quad ABCD is parallelogram. Name the principal, theorem, or definition that justifies the statement. All right. So you do odds here, and we do in video evens. Okay, so these three we're gonna do video. Okay, so ADX is congruent to CBX. That would be the alternate triangle, right? It's a parallelogram, lines are parallel, and it's alternate interior angles. That would be the principal theorem. Okay, AD is congruent to BC. That is opposite side of parallelogram are congruent. and dx is bx is diagonal of parallelogram bisect each other. Okay, so you do these three, and then the rest we do in the class, I think. I think you can do these. Yeah. Yeah, why don't you do odds here? And odds. And I'm gonna ask one of these for the survey. Okay? Alright. Have a good night.